Hey guys, today we're going to talk about another method of factoring called factor by grouping. Alright, and for this method, this comes up when you have four terms in a polynomial and you're trying to factor. So that's going to be the pattern we look for to use this method. In our first example, we have 4qr plus 8r plus 3q plus 6. So we're still going to go through what we normally would do. Is there a GCF? Well, there's not a GCF. And then after that, you're kind of trying to analyze what's the pattern we have. There's four terms. So since there's not three terms, we can't use the trinomial patterns that we know. There's not two terms. There's no perfect squares, so we couldn't use difference of squares. So this is going to be the pattern we look to use when we have four terms. So for factor by grouping, you are going to group together different parts of the polynomial. And by that I mean, like, I'm going to ignore these last two terms. I'm going to look at just the first two. I'm going to group those together. Do they have anything in common? Well, 4qr and 8r, I'm grouping those two together. They do have something in common. They have a 4r in common. And when you factor out a 4r between those two terms, you're left with q plus 2. Now I'm going to group together the other two terms, 3q and 6. 3q plus 6, do they have anything in common? Well, they have a plus 3 in common. So when we factor out a 3, we're left with q. Factor out a 3 from 6 is 2. So you're left with q plus 2. Now looking at these two here, we have the monomial 4r times the binomial q plus 2. And we also have the monomial 3 times the binomial q plus 2. They have something in common between them. They have a binomial in common. So you can kind of factor out that binomial. By that I mean, you can take the q plus 2. You're factoring that out, so you're left with 4r plus 3. If you were to multiply this out, if you were to FOIL this out, you're going to end up right back here where we started. So that means this is the factored form of this. We have a binomial in common. It might be a little harder to see how we're getting down here. You have a binomial in common. I'll draw on the side. Like, let's say we had 4r times x plus 3x, and we factored out an x. You'd be left with 4r plus 3 times x. Well, here, instead of having x, you have a whole binomial, and you're factoring the whole binomial out. So instead of having a monomial, like an x over here that you're factoring out, you're factoring out a whole binomial. It can be a little harder to see, but once you realize what it is, it's just factoring a whole binomial out. And you could also write this, if you wanted to, as 4r plus 3 times q plus 2. You can change the order of the binomials. You're still multiplying them together, you still would FOIL them. And this is what factor by grouping is. When we have four terms, we're going to try to group together different pairs of those terms to try and see if there's a binomial that we can end up pulling out to end up with two binomials being multiplied together. So if you want to take some notes down on this, they're on that second slide for you. The pattern that we're looking for, again, with grouping is either after you pull out a GCF, or if there is no GCF, if there's four terms left over, grouping is going to be what we should be looking to use. So our next example, we have 2p cubed plus 3p squared plus 6p plus 9. So first step should be, is there a GCF here? And there is not a GCF. So our next step is, well, we have four terms. Let's look to see if we can do grouping here. So let's group the first two together. 2p cubed and 3p squared. Do they have anything in common? Well, I see a p squared in common. After you factor out a p squared, you're left with 2p plus 3. Then let's look at these two terms. 6p and 9. Is there anything they have in common? Well, only one of them has a p, so there's no p's. But there is a common here, a common factor with 6 and 9. That would be a 3. So if you pull a 3 out, you're left with 2p plus 3, which is exactly what we want because that's the binomial we have over here. So we can factor that binomial out, 2p plus 3, and you'd be left with p squared plus 3. So this works, or you could say p squared plus 3 times 2p plus 3, that's okay. Either one of these is fine. They both are the factored form of this polynomial. I'm going to try one more, and then I'll have some others that you can try on your own and check with me. So our next one, we have 2mk minus 12m plus 42 minus 7k. So again, look for a GCF, and there is no GCF. There's 4 terms though, so let's try and see if grouping works. If grouping doesn't work, then we just can't factor here, but let's go ahead and check. First 2 terms, is there anything in common? Well, I see a 2m in common. When you factor out a 2m, you're left with k minus 6. And now our next 2 terms, 42 and minus 7k. When we factor this out, if there is anything in common, it's nice to keep in mind what binomial you're trying to make. You're trying to make k minus 6. So let's first see if there's anything in common. 42 and 7k, there's a 7 in common. So we're going to factor a 7 out. Now when we do this, if we were to factor out a positive 7, we would end up with 6 minus k, which 6 minus k, you could rewrite and say that's negative k plus 6, and in fact we're going to prefer to write it like that, but that compares to this binomial in that the signs are just the opposite. When this happens, what you need to do, instead of factoring out a positive 7, you're going to factor out a negative 7. Because when you take a negative 7 out of 42, you're thinking what times negative 7 is positive 42? Well, it's negative 6. What times negative 7 equals negative 7k? A positive k. And then you can go ahead and rearrange this right here. Negative 6 plus k. Well, that's the same thing as k minus 6, which is exactly what we want. So I'm going to go ahead and rewrite this. K minus 6. We also should prefer to write it like this, the highest degree first, and then the constants afterwards. Keeps everything organized, and you'll notice, like binomials, easier that way. So we can go ahead and factor out that k minus 6, and we're left with 2m minus 7, which you also could write this if you wanted to. 2m minus 7 times k minus 6. Either one of these is okay. That's your factored form here. So if you're feeling really good with these and you want to try some on your own, go ahead. If you want to try the ones in the slides, on that last slide there's 4 problems. You can go ahead and try those. I'm going to go through examples of them right now, so you can check your work with mine as we go. I'll try to put 2 up at a time so you can check your answers if you just want to by skipping ahead. So the first one, we have c minus 2cd plus 8d minus 4. So again, look for a GCF amongst all the terms. Don't see any. So we're going to try to use grouping here. Looking at the first 2 terms, can we group anything together? Well, you can group together and say you have a c. So you're going to be left with, when you factor out that c, you'll be left with 1 minus 2d. Your second 2 terms, is there anything in common between those 2 terms? And there is. Looks like we can factor out a positive 4. And if we factor out a positive 4, we're going to be left with 2d minus 1. But we run into that same problem here, that 2d minus 1 is almost the same as this, but we need to reverse our signs. So that means we should factor out a minus 4. When you factor out a negative 4 instead of the positive, you're left with negative 2d and plus 1. Over here, that's the same thing, it's just written in a different order. I'm actually going to rewrite it over here as negative 2d plus 1. That we have the constant later in the standard form. And now you can go ahead and factor out that negative 2d plus 1, and we're all done. Or if you wanted to write it as negative 2d plus 1 times c minus 4, it represents the same factored form. Changing the order of the binomials is okay. So that was our first one here. Our second one, we have 3bc minus 2b plus 15c minus 10. And we are going to first look for a GCF. I don't see a GCF. Notice that we have 4 terms, so that should kind of put a light off of we should try grouping. There's 4 terms. So look for your first 2 terms. Anything in common? I see a b in common. After you factor a b out, you're left with 3c minus 2. Your next 2 terms, is there anything in common? Well, the only thing I see in common is a factor of 5. And now we're going to set it up. We're going to try to set it up so we have 3c minus 2 when we factor out a 5. And to do that, we need to take out a positive 5. That'll get you to the 3c. And taking out a positive 5 here would mean you have a minus 2 left. And our binomials match up perfectly. So we're going to end up with b plus 5 times 3c minus 2. Or if you wanted to write it as 3c minus 2 times b plus 5, that would be perfectly fine as well. There's your factored form. Alright, we'll do the last 2 and then you'll be on your own for the rest of your practice. So our next one, we have 2x cubed minus 3x squared plus 4x minus 6. So first thing you should look for, GCF. Is there any GCF amongst all the terms? There is not. So let's go to grouping because we have 4 terms. First 2 terms, I notice there's an x squared in common. So I'll be left with 2x minus 3 when we factor. Second 2 terms, I notice there is a 2 in common. So we're going to factor a 2 out. Now I want this to be 2x minus 3 in here. So in order to do that, I would have had to take out a positive 2 between those 2 terms. Our binomials match, which is great because then we can go ahead and factor further and we'll be left with 2x minus 3. That means grouping works here. And I'll leave it at this. This is our final answer. You also could have this binomial first if you want to. All right, on to our last one. I'll make a little space for us. Our last one, we have 6xy plus 24x minus 3y minus 12. First thing we should look for, is there any sort of GCF amongst all of the terms? And for this one, there actually is a GCF. You can pull out a 3. When you pull out a 3, you're left with 2xy plus 8x minus y minus 4. And now we're left with 4 terms. So if we can't factor any further, then we're done. We just have the 3 as a GCF. But we should check to see if we can use grouping when we have 4 terms. So let's try. If it works, I'll use a nice little bracket here. First 2 terms, 2xy and 8x, well, they have a 2x in common. And we're left with y plus 4. Now our next 2 terms, negative y and 4, well, they don't have anything in common, but if you look, negative y and 4 is really close to y plus 4. If we wanted to make this a y plus 4 in the binomial, what could we multiply negative y and negative 4 by to get that? And the answer is negative 1. So you can factor out a negative sign between the 2 of them here, and you're left with y plus 4 times that negative 1, and we're set up in good shape here. We have an identical binomial. So we'll have 3, then we're going to have 2x minus 1, and the y plus 4, and then our job is done. We are completely factored. I do, on a side note, want to point out, if you did not factor this in the beginning, with a GCF, your final answer might look something like this. If you get down here, if you don't do the GCF in the beginning, you might end up with something like this. But this is not completely factored because if you look at the binomials, well, the one to the right is good, but there is a common factor between the terms in this binomial. You could factor 3 out, and you'll be left with the same answer that we have over here. So if you don't do the GCF in the beginning, it's going to show up somewhere. Usually at the end, you'll notice that there's a common factor within, in this case, the binomial, that you can factor out, and then you'll be completely factored. So if you don't do that GCF up front, which you should be getting in the habit of doing that first, but if you don't, it'll show up somewhere that you can pull it out, and then you're completely done. Alright guys, that's all we have for today, so go ahead and try some of these on your own. I hope we have a good day.